Hi, hello everyone. So today we're working on a calculus 3 problem or math multivariable calculus problem where we have a double integral from reading this from outside to inside, the integral from 0 to 1 with respect to y, the integral from y to 1 with respect to x, and the integrand is e to the x squared. All right, so I'd like to go ahead and evaluate this using, think of it as an iterated integral here. So I'd like to, first of all, try finding what the integral of 1 to y e to the x squared dx is. And then from there, integrating from 0 to 1 of whatever that expression is with dy. Well, the problem is this. I do not know what the antiderivative is of e to the x squared. Yeah, I'd like to use the fundamental theorem of calculus on this, and if I'm going to do that, I want to find the antiderivative of e to the x squared, but I can't. So, because it's not not an elementary function. Okay, in other words, not like a function you can just integrate and get an answer for. So the solution here, when you're working with these types of problems in multivariable calculus classes, to look at the region and try to reverse the order of integration. So it's dx dy. I want to write it in dy dx, but I have to know the region to find my limits of integration first. Okay, so first thing I notice here is that your y's go from 0 to 1, right? Because y here stands for the limits out here, and then x, the inner variable of integration, tells you the boundaries for these functions, y and then 1. Okay, so if we draw this out, I'm going to make an axis here. Here's y and here's x. So if you start with, it doesn't matter what you start with. Let's start with the functions. You're looking at the region for which x is between 1 and y. You can think of it as two functions, so x equals 1 and x equals y, and the stuff that's in between them essentially here. So here's 1. X equals 1 is just a vertical line. And then x equals y is a straight line. So this would be equals x. And then you're bounding this from y equals 0 to y equals 1. Oops, sorry, this is less than or equal to 1. So this would be y equals 0. And this is actually y equals 1. That's where they meet. Okay, so you're essentially looking at this region right here. And what I'd like to do now is rewrite that into this double integral that I had before in terms of this region with respect to dy and dx. So how do I do that? Well, let me get rid of this stuff. So when we're setting up our limits of integration, what I like to do is I like to look at the region that I have, and I'm going to draw a arrow, and the arrow that hits the first function that bounds the region, that's your bottom limit. So you would hit 0, and it's y equals 0. And then the top limit that you hit here by that arrow would be y equals x, so that would be x. And the x values go from this point to this point, so that'd be 0 to 1. So that's the equivalent integral in terms of dy and dx. Sometimes we call that a type 1 region. What we had before was a type 2 region when you switch the order as x and y. When you have dy dx, it's type 1. Dx dy is type 2 specific. All right, so this is what we'd be integrating. And can you always integrate when you change an order? No, you can't. But if you can, like in this instance, great. So if we integrate e to the x squared dy first, let me write that out. This would be the integral that goes from 0 to 1 of, well, the integral of the x squared with respect to y would be y e to the x squared, because x is just a constant here. Okay, so that'd be y e to the x squared. And we would plug in x in for y, and then we would plug in 0. And for so again, y is what takes the limits of integration. 0 times e to the x squared. And this is what you would get. This wipes out, and then it comes down to 0 to 1 x e to the x squared dx. Okay. And if you integrated this, you'd have to use a u substitution. You let u equal x squared, and your du would be 2x dx. Now, if you wanted to work on this on yourself, sorry, I should have said stop the video from there. And then when you rewrite this, this would have become the integral that goes from 0 to 1 e to the u times 1/2 du. Okay. And you would have gone 1/2 e to the u as your answer from 0 to 1. And yeah, and additionally here, by the way, I did change the limits of integration. When x is 1, u would be 1 squared or 1. When x is 0, u would be 0. All right. So we would get 1/2 e minus 1/2 e to the 0. Yeah, so we use the fundamental theorem of calculus, or 1/2 e minus 1/2, because e to the 0 is 1. So that would be my answer. So the most important thing is to realize that, yeah, sometimes you're going to have to change the order of integration here, like we did, in order for you to integrate. Sometimes you cannot do that. You cannot reverse the order so easily. Sorry. Yeah, most of the time you can rewrite it, and then you can maybe sometimes integrate. That's what I meant to say. But sometimes you'll rewrite the integral and you can't integrate it because the integral is still too hard. It's very rare, but just take that into account. So again, it's just a matter of, you can't do the integral at first, try to rewrite it, and hopefully you get something nice that turns out like we did here, and you're good to go. All right, well, thank you for your time.